this topic or in this video, I'm going to discuss statics of rigid bodies. The first topic that I'm going to discuss is about resultant of concurrent forces. First, let us define what mechanics is. Mechanics can be defined as that science which describes and predicts the conditions of rest or motion of bodies under the action of forces. Uh, it is divided into three parts: mechanics of rigid bodies, mechanics of deformable bodies, and mechanics of fluids. The mechanics of rigid bodies is subdivided into statics and dynamics. The former, meaning ang statics, the former dealing with bodies at rest, and the latter, which is dynamics, deals with bodies in motion. So in this part of the study of mechanics, bodies are assumed to be perfectly rigid. So no deformation at all. That's the assumption. Actual structures and machines, however, are never absolutely rigid and deform under the loads to which they are subjected. So bali sa statics, ang assumption is rigid ang body, dili siya mo-deform. And ang deformable bodies is mo-deform siya. I-consider na ang deformation. Maski o gamay, consider yapon ang deformation. But these deformations are usually small and do not appreciably affect the conditions of equilibrium or motion of the structure under consideration. That is why i-assume siya na assumed to be perfectly rigid, kaya ang deformations gagmay ra. Pero sa next nga subject, mechanics of deformable bodies, consider na ang deformation. Okay, so first that we need to understand here is about force. Ang idea about force. Now, a force represents the action of one body on another and is generally characterized by its point of application. This one, point of application, its magnitude, kini 50 kilonewtons. Magnitude na. O kung scale na to, ang length sa arrow, mao na siya ang magnitude. And its direction, kining 30 degrees. So, direction niya is either referred sa horizontal axis or referred sa vertical axis. Concurrent forces, to first topic, concurrent forces, however, have the same point of application. So, bali sa concurrent forces, dili na mag-matter ang kining point of application kay same man siya. So each force considered in this topic will thus be completely defined by its magnitude and direction. So sa tanan forces there, we will only consider magnitude and direction. Wala na ning point of application. Yeah. For this topic, for concurrent forces na analysis. So, experimental evidence shows that two forces P and Q acting on a particle A, like this one, two forces P and Q acting on particle A, can be replaced by a single force R, which has the same effect on the particle sa figure C. So, bali kining duha ka forces P and Q, we can replace these two forces by a single force R, having the same effect. Eh, ano. Now, this force is called the resultant of the forces P and Q and can be obtained as shown in figure B. So, ang ang pamaagi daw pag-replace or one way of replacing P and Q by R is kining sa figure B. Okay. So we can do this by constructing a parallelogram using P and Q as the two adjacent sides of the parallelogram. This one, parallelogram. The diagonal that passes through A represents the resultant, kining R. So this method for finding the resultant is known as the Parallelogram Law for the addition of two forces. This law is based on experimental evidence. It cannot be proved or derived mathematically. So let us have some sample problems para ma-illustrate nila how to get or how to solve for R if we have two forces. So our first sample problem is this. The link in the figure shown is subjected to two forces F1 and F2. Determine the magnitude and direction of the resultant force. Use parallelogram method. Okay. We have this one, and what we will do is we construct a parallelogram. Okay. So, i-plot na to ang F1, 600, and then F2, 400. So, mag-construct ng parallelogram, kopyahan na to 600, and then also 400 values. And ang diagonal is muna na resultant. Now, ang kondisyon ani is dapat, tukod sa kay parallelogram, dapat ang tails sa two forces mag-meet siya. O tail, like for this force, tip man tip, tail na siya. Sa 400 tip, tail. So, ang tail sa duha ka forces na, dere. Dapat, ang resultant po, kay sa parallelogram, there are two diagonals. This one, diagonal number 1 and diagonal number 2. Dapat, ang resultant is that diagonal that passes also the point of intersection sa duha ka forces na, dere. So, this must be the resultant and not this diagonal. Okay. R, no? And draw na mo yung direction 30 and then also 45. Okay. This is not difficult. Yeah. You just have to understand. Okay. First is kung ang angle, interior angles sa parallelogram. So, we have 45 and 30. We can solve for this interior angle. That's 105. It's very simple. That's 180 minus 45 and minus 30. 105. Now, since parallelogram siya, 105 ni the other one, 105 din. And since the total angle in a parallelogram is 360, then we can solve for this one. How to solve for this one? Simple. 360 minus 105 minus 105. The result is 150 divided by 2, okay, equal man dire, divided by 2, and then C75. Okay? So, after constructing this parallelogram, we isolate or we separate one triangle. Identical mo yung two triangles. This triangle of triangle 1 and triangle number 2. Okay, suppose we isolate this one. Kana. So, i-redraw natin i-separate ito ng triangle like this one. Okay. So, we have 600. This side is 400. So, same man sila dito. 400 or 75. Now, always remember this. Pag-isolate sa triangle, aside from the given two sides, the third given value is the included angle, meaning is the angle between the two sides. Always gina sa nga value. You can always find this value. Because in a triangle, you can only analyze it if you have three given parts. In a triangle, we have three sides and three angles. Diba? So you need three parts para ma-analyze nimo ang triangle. Pag two parts only, like two sides lang, dili mo ma-analyze ang triangle. Okay, so since we have two sides and one angle, we can solve this one by cosine law. Okay. Kaya sa sine law, you can only use sine law if opposite parts are given. Meaning, if one side is given, dapat ang opposite angle given side. But in this case, wala man. Given side, no angle. Given side, no opposite angle. Given angle, unknown ang opposite side. Therefore, we can only use cosine law. So, review sa triangle, this will be our equation. Simple review, kung saan ang angle na given, ang opposite side will be on the left side. So, r squared equals 600 squared plus 400 squared minus 2 times the product of the two sides and then cosine sa included angle. So, using your calculator, R is 629.1. This is the magnitude. And since ang resultant nato is a force, and a force is a vector quantity, dapat it will possess magnitude and direction. So after this one, determine na to ang direction. Direction of R with respect sa horizontal axis. If you look at this one, the direction of R is this. So therefore, we will first solve for this angle. And then later on, mag-add tag 30 para sa direction. So i-solve natin this one. Theta. Okay. So to solve for theta, pwede na tayo magamit o cosine law since given naman opposite parts. We already have the value of R. We can use sine law. Okay, sine theta over opposite side, sine 75 over opposite side R. So, this value, 629.1, substitute nimo dire, and you can solve for theta is 37.89. So, therefore, the direction of R will be this one, theta plus 30. Ang resultant nato is this, 629.1 newtons magnitude and direction, 67.89 degrees from the positive x-axis. Yan na ang parallelogram law. Okay. After constructing the parallelogram, you extract one triangle and make sure na makuha nimo ang angle in between the given two sides. Sample problem number 2. Letter A. If FB, referring to this figure, if F sub B is equal to 3 kilonewtons and theta equals 45 degrees, determine the magnitude of the resultant force of the two tugboats and its direction measured clockwise from the positive x-axis. And then letter B, if the resultant force of the two tugboats is 3 kilonewtons directed along the positive x-axis, determine the required magnitude of F sub B and its direction theta. So letter A, If FV equals 3 kilonewtons and theta equals 45 degrees, determine the magnitude and direction of the resultant force. So, plot na to. We have FA2 and then 30 degrees ang angle. And we have this one, FB, 3 and then 45 degrees. So, construct a parallelogram and one yung resultant din. Okay. Always remember ang tails must meet at a common point as well as ang resultant. Dito po siya mo. Dito po yung tail. Para dili ka masayop kung saan ang diagonal may consider. So this is the resultant. After this, extract one triangle, and then separate we have this. Now, complete natin yung angle kay 2 ni siya chosen eh. So, since 75 ni, 75, okay. One way of getting this one is cut off 360. 360 minus 75 times 2, and then the result divided by 2. Or simply, 180 minus this one, 75, this is 100. So we have this 2, 3, and then R, 105 cosine lahat. So, basic na equation. R is 4.01 kilonewtons. And then, para sa direction sa R, this is the direction of R. So, we need to solve for this angle. Para i-subtract na to sa 45 later on. So, we'll solve for this. Theta, phi. By sine law, sine of phi over 2, sine of 105 over R. So, you replace R by 4.01. And makuha ni mo ang 28.755. So, i-subtract na ni mo, this is your phi, and this is the direction of R. This one. So, this will be 45 minus phi. Therefore, ang na to, resultant is 4.01, 16.245. It's simply 45 minus this one, 58.755. Now for letter B, if the resultant force of the two tugboats is 3 kilonewtons directed along the positive x-axis, determine the required magnitude of force F sub B and its direction theta. Okay. Let's plot. We have FA2. Okay. Now, ang given is the resultant is 3 kilonewtons and it's directed along the positive x-axis. This one, positive x-axis. Not the resultant. Okay, 30 degrees. Given ang resultant na 3. And then ang direction niya. So, to solve for FB, nag-usap tayo parallelogram. So, you draw the line. And then this one. So, i-connect na to. That's FB and then theta. So, let's consider this triangle. This is theta. Now again, ang given two sides kay R o 2. So, ang makuha itong angle is this one. It should be the included angle. And this is equal to 30. Kaya, pareha lang na. If this is 30 sa din. And we can use cosine. By cosine law, we can solve for FB. It's 1.61. And then solving for theta, sine lang sa ito. Sin theta over 2 equals sin 30 over f sub b. and theta is equal to 36.260. So, inana ang parallelogram. Now, if you have more than two forces, how do you get the resultant using parallelogram law? Okay. So, consider a particle A, this one, acted upon by several coplanar forces. Since the forces considered here are all pass through A, they are also said to be concurrent. The vectors representing the forces acting on A may be added by the polygon rule, figure B. Yan eh. Polygon rule, tip-to-tail method. So, P, plot mo ang P, and then followed by Q, then followed by S. And then i-connect mo ang gap from point A to the tip of S, draw a line, that would be the resultant. That's the polygon rule, or the tip-to-tail method. Now, since the use of the polygon rule is equivalent to the repeated application of the parallelogram law, the vector R thus obtained represents the resultant of the given concurrent forces, that is, the single force which has the same effect on the particle A as the given forces. So instead na three forces ang i-consider na to, isa na lang, R na lang, having the same effect as the original three forces. As shown, the order in which the vectors P, Q, and S representing the given forces are added together is immaterial. Immaterial, it means na even if you will start with Q and then P and then S, or Q, S, and P, R will still be this one. Okay? So, bahala unsa na force yung ang mag-start. P ba, Q, or S. Ang sequence ba, dili mag-matter. The same result for R. Manang nakasulat diri immaterial. Dili necessary na alphabetical. So to illustrate on how to solve for R, okay, and specify diri na the use of the polygon rule is equivalent to the repeated application of the parallelogram law. Ay, repeated So, meaning to say, mag-construct ta og not only one parallelogram, more than one parallelogram to construct. So, let us start with this particular. Let us start with P and S. P and S. Since kung mag-construct ka og parallelogram, you only need two forces. And then mag-draw rin ka og parallel sides niya, nakuha ni mga resultant. Like this one. Okay? So, we have forces P and Q. We can get the resultant. Resultant for P and S only. Dili ang total resultant. Okay? For P and S only. So, from three forces, na-reduce na to siya, and two forces, na-reduce na to into one. So, ang bilin ani is this one, RPS and Q na lang. Kina-replace naman na to ang P and S by R, RPS. So, ang next ani is, we'll construct another parallelogram containing or involving RPS and Q. Like this one. So, we have RPS and then Q and S. So, construct our parallelogram. This diagonal R is this way. Same lang na. Even if mag-start ka og P and Q, so you can solve for the resultant of P and Q, and the next is combine mo with S, the same R. Or you start with Q and S, and then after that, ang resultant sa Q and S, i-combine mo sa P, the same R ang gawin. So, that is why, kung kung solve ka problem involving more than two forces, laborious na yun, dugay mo man. It will take time to solve for R because you need to construct more than one parallelogram. But the process is the same. Na every time mo construct a parallelogram, always find the angle between the given two sides. Ano? Okay. Resolution of a force into components. Panata idea, we have seen that two or more forces acting on a particle may be replaced by a single force which has the same effect on the particle. Resultant na siya. Conversely, a single force F acting on a particle may be replaced by two or more forces which together have the same effect on the particle. These forces are called the components of the original force F, and the process of substituting them for F is called resolving the force F into components. So, to illustrate, yan sabi, parehan nyo. Same lang if, okay, same lang, but we can have several sets of components para ma-construct o parallelogram. Okay. Bali, same magnitude and direction of Q and P, but then okay, this Q is different from this Q and also different from this Q. Same with P, different magnitude, different direction. But when combined, they have the same magnitude and direction sa resultant. Okay. So same resultant, different components. So to illustrate, we had let's have this. Suppose this is our force, our resultant. We can have these components. This one, yellow, ana, different components. Or this one, that's it. So same resultant, different components. But our purpose here is this one. Na given a force, we can resolve this force into components along the x and the y axis because it is easy to analyze horizontal and vertical forces rather than considering inclined forces. So this will be our second method in solving for the result. So I hope that you have understand or you have learned something about parallelogram law. Thank you for watching.